Same, is it?
All right, let's start. Whenever you are ready, feel free to take it away.
We're fixing a minor problem with the password setting, so just a second. I'm restarting the pod, so everybody who just got an authentication problem, it should go away. All assuming I actually typed virtual contribute accurately.
Yeah, it's working correctly now, Jason.
Waiting for approval to join the session. Brian? Okay. Yeah, that will be Megan's job to handle that, to see whether or not you show up on screen. Okay, stop share, new share, presentation. Where did I put my controller window? There you are. Sorry, I was trying to find where Chrome had stuck my presenter's control window. It disappeared because ha. All right, for those following along on the presentation at the moment, if you double click the slides, it will bring them up to the primary screen for everybody, and we can go from there. Okay, so thanks everybody for coming out. This is Kubernetes 102, building blocks in practice. Now, the first question that everybody's going to have is, what do we actually need to do this workshop? Well, it is actually a workshop. We can actually do things hands-on. We're not just going to talk about things, we're going to do them. So first things first is we have a project on GitLab. Go ahead and pull that down. If you can't, let us know. We'll get you a way to get to these things. Adrian, no audio. That unfortunately is just you at the moment. Platform issues. So the first thing we'll ask you to do is go ahead and clone the actual exercises that we're going to make use of. These exercises are designed so you don't have to be at the presentation today to actually do them. You can do them in your own time. So feel free to do that later if you choose. If you're going to follow along with us today, you're gonna need a cluster to work with. In order to make that available to everyone, we have created a K3S sitting in GCP, and it is very, very big, but you need authentication to get to it. So if you go to the link that you see here, which is also in the docs, but I'll go ahead and copy it over here to the chat for everybody so it's easier to get to. Go there, it will ask for authentication. The username is lab. The password is virtual contribute. Yes, it's a long password and I apologize, but I had to make it hard for bots. Repo for the, yep, sure, I can throw it in the chat.
The username password's also in the doc,
Yes.
at the top of the doc.
Mm-hmm. Where's my controller app? There you are. The second thing is, once we have that file downloaded for everybody, we're basically going to convince kubectl that this is where its file should be at. The reason we did it this way, and we're going to do it through exporting an environment value, is we don't need to inadvertently pollute your kubectl configuration by adding our settings into it just for a workshop. So the first thing you'll do is in your terminal is export kubeconfig equals, and then the backtick pwd backtick /k3s.yaml. What this does is this tells kubectl that it should read its configuration from this file that you just downloaded that is explicitly for this workshop. This way we don't touch anything that we don't intend to on your working system or leave trails you find 6 months later and go, where was this thing? Once you have that downloaded and you have set kubeconfig in your environment, we want you to make sure it works by going kube control get nodes. And everybody should see a instance 1. And that's the primary one that we're working with. To the slides. I've added. There you go. So we're watching the chat, as everybody can see. Is anybody having success or having problems? Did they hit a 403? Yeah, 1 good, 2 good, 3 good. Okay, we're up to 1 person's all the way done. It's completely working. Awesome. I can see in the instance 1. Woo! Great. Project empty. That's a new one. Yep, Philip, don't worry. That's a reason we have 45 minutes to do this. We will use all the time we have available, and we're going to make sure everybody understands the concepts that are actually being used here. We can throw buzzwords around all day long, but if you don't understand it practically, they're just words. Yes, Matt. This guy typoed the first time he pushed the project. Yeah, you'll note the empty project is the typo, by the way. Unfortunately, I don't have the rights to delete the project, or I would have gotten rid of it last year. Okay. James, we'll get to kubectx later, and we will show you what's actually required to hand type this command out and why we actually recommend kubectx. Tiffany, they are in the Google Doc, but the username is lab. The password is virtual contribute. Oh, James, we're going to show you so many tricks. It's not even funny. Now, we do have 148 people watching this, so we will move forward very shortly. Joanna, thank you for resharing the docs link. Okay, I'm just going to absolutely mute my Slack because unfortunately I'm getting a bunch of pings. And it's blocking me being able to read my own chat in my session. I'm actually trying to figure out how to tell it to mute Slack, but not other things on my system. So I'm just going to close this, and I'm going to tell my system to mute all notifications. Do not disturb for 1 hour. Yeah, I just told my whole system go away for an hour.
Yeah. Yep.
Yeah, Christoph, I could just close Slack, but unfortunately, there's times when I'm actually like emergently needed. So thankfully, we have 3 presenters. So if I get called away, there's always that. Okay, so we've given everybody a couple of minutes to get everything working. Does anybody have a blocking issue before we get started? Not seeing anybody say they are having one, so we will move along. kubectx is a shell script, so you can either use kubectx and download it, or you can use the distro package if it's available. So moving on, the workshop leads for today are myself and Robert, who is having audio video issues today. And of course, we also have
Myself, Gerard Hickey. Nice to meet you.
for a point of context, last year at Contribute NOLA, we actually had a wee bit of fun with poor Gerard and went, oh, good, you started today. We have a presentation in 4 hours. You know Kubernetes, right? And literally drug him in screaming to this presentation and workshop.
And we were doing changes to the workshop as we we're working on it too. Making all sorts of changes and patches. It was fun.
Iteration, what can I tell you?
That's right.
So myself, I've been with the company now for 3.5 years. Robert's been with us, what, a 2.5 years? And Gerard's been with us just about a year. Just about a year.
Yeah.
The three of us work in distribution. We are constantly working on the Omnibus, the Provisioner, which is Terraform and Ansible, and our cloud native containers, as well as our cloud native charts that allow us to deploy GitLab into Kubernetes. So we know that we know a lot more than a lot of people, but also sometimes it's hard for us to forget that we have a baseline of knowledge, and we want to be able to actually explain that to people and show them the value of how we do things and why. That's what we're trying to do here today, is to not just say, look at all the magic we do, but actually explain what the things we're doing are, right? What are the basic components of how an application is put together when using Kubernetes? What exactly do you do to actually deploy a basic Kubernetes native application? We want to be familiar with some handy utilities like kubecontext or kubectx, as well as how to actually work with these clusters and why these utilities are super handy. We also want everybody to be able to walk away and have at least a high-level path of how to access Kubernetes applications and how that works. So first off, what actually is a container, right? So if anybody would like to help answer these questions or respond to these questions, feel free to hit request permission. Megan, have fun. If nobody wants to, I mean, I'll give it a couple of seconds and then I'll just give you an explanation of what a container actually is. That's okay. So I do have, Jason Collier says, it's like packaging for the code for an app with its dependencies. James Sandlin says it's something created with Solaris 10. You're both right and wrong, because a container is not a jail, but a jail is a container. Yes, Susie, Shroot on steroids is a good way to put it. It's a runtime of a Docker image. Close you go. Isolated process with a file system, Nico. Not a bad way to put it. Yeah, Jeff, definitely not virtual machines, and I'll explain that in detail later. So let me explain the simplest high-level answer. It's, remember, because that's what we're looking for here, is an easy way to understand them and a clear way to describe them. A container is a way of packaging an application so that it is portable, yes, contained, hence container, and immutable, right? So a container is a way of literally taking a stack of the application, its runtime requirements to actually execute, and packaging that up in an immutable form that you can hand to someone. Yes, they can add more to that container later, but it's no longer the same container at that point. But you can go, this one with my tag on it is exactly what you're supposed to have. That's what a container is usable when it comes down to how you do an application. So what is Kubernetes at a high level? Okay, I've seen orchestrator, I'm seeing management system, I'm seeing coordinator. Okay, so it is all of those things. Kubernetes is an orchestration platform designed to provide a means of declarative, scalable, resilient applications by weaving both containers and software-defined networking together. The idea is that you can have a platform that you can deploy onto with a clear syntax, although yes, it can seem like black magic. That syntax is replicable and not vendor bound, so that you can deploy it anywhere that supports the official behaviors. Its job is to start containers, keep them running, and make sure they're still running. That's what its job is really about. You can then tell it all kinds of fancy things about where to put things, a high CPU, put it over there, don't put it in the Americas, whatever you want. But in the end, its job is have containers running, give them the resources that they need to operate, and keep them running. So what exactly is our goal today? I don't need anybody to answer this one because I should know as a presenter, right? Well, we want to expose you not just to the buzzwords, but the practical building blocks of how containers and Kubernetes are used to build cloud native applications and deploy those in truly accessible ways. So let's get ourselves started with a little bit of toe wetting. We've already made sure that everybody can get in and see the nodes. So let's learn a few things. Run kubectl cluster info.
And for anybody that's having problems with the labs or anything, I am doing a terminal session there. So you'll see everything that we're doing through the labs and everything in the presentation is in that terminal window. So if you're getting something you're not expecting, take a look at the terminal window. And if it's different, we'll try to resolve that. Hit us in chat or in the doc.
Philippe, I would agree that alias K kubectl can be really handy. You do have to be careful though, because there is actually a utility. Yeah, for the sake of this particular session, it could work out if you don't feel like typing kubectl all the time. Okay, so the good news is everybody managed to do that. They got to see what was going on in the cluster, some basic information, and they got to look at the namespaces. And I'm seeing a whole bunch of people making namespaces because I have K9S on the side and I'm watching the namespaces window and I see it scrolling, but I only see 26 of them. I'm waiting to see a few hundred.
Trying to get a few more. It's good.
Okay, so I'm seeing 48, which means there are 44 of them that have been added since I started the cluster. So we have solid progress in practice. So now that we've got, whoop, there's 49. See, people are keeping up. Oops, I did not mean to go forward a slide. So the next thing you want to do is run K with the TAC-N flag. The TAC-N is short for TAC namespace because nobody wants to use all of those keys. Whatever your username is, and do get pods. And you should see that there's actually nothing running in your namespace.
Oops, have one running.
And Gerard, you're ahead of the practice.
Yeah, let me kill that for everybody so they can see what they normally see.
Yeah, Laura, you shouldn't have localhost 8080. Does anybody else bump into that problem? If you do, let me know.
Actually, I'm gonna clean my namespace in case I have other things out there. So if you're following along, don't do what I'm just gonna do.
Oh, do I have the name typed wrong? Is that it? Do I have the export typed wrong? Gerard, can you do me a favor? Can you make your terminal more widescreen than portrait? Apparently, there's an overlay that's making it hard to read for some people.
Like so, is that helping a bit?
Much better, they say.
Sounds like it is. Okay. Thank you for letting us know.
Nope. I see. I have this wrong. My apologies to anybody. If I have this line incorrect, tell me.
Cube config?
Yeah, somebody was saying that like Chrome saved it as k3s.yml instead of k3s.yaml.
Yeah.
I see now almost 60 namespaces. We're making progress. Yeah, Matthias, if you're bumping into kube control specifically from microK may or may not be doing some magic of its own in the background. So I apologize. Okay, so if nobody minds, I apologize if a few people have had hiccups. Make sure that you're exporting whichever k3s.yaml or YML that you actually get, just in case they decided to mess things up. And we'll go ahead on to the next slide. Okay. So now let's take a quick look. We have said what's in your namespace. Let's look at what's actually in the kube system namespace. The kube system namespace is, as it sounds, this namespace in which most of the system processes actually behave. Kube system is where you're going to find a metric server. If Helm 2 were installed, it nominally installs itself into the same namespace. You'll find a load balancer, an ingress, and a few other things that are living in here that provide services to much of the cluster. Now, when I say I see a whole bunch of namespaces, remember last slide before I had you create a namespace, I said, get NS? Well, run kube control get ns, which ns is short for namespace. Now you should have a whole lot more lines. So now that we've got a basic understanding, you know what a namespace is. I guess I should explain that, shouldn't I? Should do better at that. A namespace is effectively your working area. It's like a project in GCP or a similar thing in AWS. I don't remember if that's the exact language that they use. Yeah, Jason, there's a lot of them now, and there should be more coming shortly. But I'm glad to see that most people got it working at this point. Inside of a namespace, these are a way to separate config maps, secrets, pods, services, all the objects that applications will actually use. That has another impact, but we'll touch on that one later. Essentially, it's a way to actually componentize where your applications are. So this way, we're deploying everything through these exercises into individual namespaces so that we don't have, say, Kenny deploying lab 3 and Matthias also deploying lab 3 and it going, hey, there's already a pod named lab 3. Okay, so let's simplify a few things, right? So we mentioned kubectx. If you have kubectx installed at this point, you get a fun little utility called Kubernetes. If you run Kubernetes now, you will actually be able to see the entire listing in that, but in a much more condensed fashion. You can also run Kubernetes and then set your username, and it will now set your active namespace. Now, why is this handy? Well, first of all, you probably don't want to be putting tac and username into every single command. This will save you the, oops, I put it into default, and somebody go, I can't do it because lab 3 already exists in default. But also, because if you wanted to change your namespace like this is where Kubernetes comes in handy. You actually would end up typing out an extremely long command. It would be kube control, config, use context, point to the current context. I believe it's set, and namespace equals namespace. You end up with this string like this long, and you have to remember the incantation and what the name of your current context is and all these fun little things that you don't want to worry about to just go, please set the default namespace to my namespace. Okay, so now we're going to have a little bit of fun. It's story time. We're going to pull some selections from an illustrated children's book made and distributed by the Cloud Native Computing Foundation, one of the primary sponsors for the Kubernetes project and all the surrounding items around it. We won't cover every page, but only the key items we actually need for this particular workshop. I happen to have a physical copy of the book, but for the sake of the presentation, we're going to use images available for free from the CNCF's own website. If you want to know where the sources of these came from, you can see our facts section of the workshop document, and you will be able to find the links to go look at these in full detail later. They are hilarious. They are cute. And yes, they're full color. So we're going to skip just ahead in the book because like I said, I don't want to read every single page, but let's skip. So the book is Phippy Goes to the Zoo. So we have a couple of characters here. We have Phippy and Z, and what we're going to do is we're going to go right into the stories that we have. So for this slide here, the first animals they came upon were the size of squirrels. Furry and Blue, each little animal carried a tiny box as they unceasingly zipped back and forth. Those, said Vippy, are pods. All day, all night, they run back and forth, carrying their little containers. Is that all they do, Aunt Fippy? Yep, Z. For their entire lives, that's all the pods do. They run. So what is a pod? Right? So a pod is effectively a unit of work. It is a way to describe a series of containers, the volumes they might share, and interconnections that those containers within the pod may need. It also allows us to do things like expose ports and default configurations. You can have a pod that has a single container in it. You can have a pod that has 10 containers in it, although 10's a little excessive. They provide you a way to be able to set the things that an application actually needs. Its environment, its storage if it's needed, other information that needs to be fed in, whether it's configuration files, application secrets, where is my Gitly server, for an example. That is a description of a unit of work that Kubernetes, as I said before, his only job is to make sure that that stays running and manage its health. If it's up, it's good. If it's failing, we need to do something about it. If it gets removed, well, maybe it should get replaced. We'll cover what does that in the future. So on to lab number 2. Let's create ourselves a pod. Now, if you have used Kubernetes to set your namespace, you don't necessarily have to use the TAC and username arguments throughout the rest of this presentation. They're there just in case you don't. So we have a pre-made pod configuration that is available for everybody to use. It's in lab 2, and it is literally called pod.yaml. So we'll call kubectl apply tacf pod.yaml. And what we're doing here is saying kubectl, please apply the configuration provided by this file. Inside of that file is the definition of a pod, a very simple pod. But it's an Nginx, so it's a web server. It's not doing anything. We're not going to provide it any content. We're not going to give it any fancy configuration. We're just going to go, stand me up an Nginx. Once that is done, we'll actually see that come up. If you want to know if it's there, the first thing you can do is kubectl get pods again. Now, I'm definitely seeing a few of you at least do actually have some of these things up, because I can, looking at Dustin's, and I see one there. Yeah, Gerard might be using a fancy shell. Yeah. Okay, so now that we have a pod up and running and we can see it, we can actually access that pod by using kubectl port forward. So what you're going to want to do is kubectl get pod, grab that name, and then run kubectl port forward the pod name you just copied, and then you want to say 8080:80. What we're saying is port forward my local port 8080 to the containers port 80. Yeah, Alejandro, we're not running that on your machine. So yeah, if you hit localhost port 80, it's going to be a weird day. If you have localhost port 8080 already running on your machine, yeah, you might actually hit a port conflict. So, Katrin, your username is whatever you want to be. So Kayleen Weber or me? Doesn't matter. Okay, so once you've run kube control port forward, it will actually spit you out a couple of URLs. And then once you copy that URL and put it into one of your web browsers, whichever one you use, then you'll actually have direct access, basically through an SSH tunnel, or similar to an SSH tunnel, I should say, to the pod that you're running against. And you can see that you're actually now directly connected to that pod. Now, imagine if you had to do this, whoops, imagine if you had to do that for every single thing, and then you had to put a load balancer and connect that by hand and all the connected ports. And like, imagine trying to do that from the standpoint of an engineer that's just trying to make an application and a website work. That'd be bonkers, right? Well, we'll come back to that in a little bit. So next in our story, a group of iguanas gathered near a large slingshot along the shore of a pond. An island stood in the center of the water. An iguana threw herself into the slingshot, and the other iguanas launched the little beast forward toward the island. The deployments release a group onto the island. Right now, they're trying to get 3 out there, said Phippy. At the moment, another iguana rocketed into the air, but missed the island with a colossal splash in the pond. Phippy said, if they miss, they just keep trying until they get as many as they need. So deployment is basically a description of pods, plural, which includes things like replicas. How many do I want to have? How many must I have healthy? And they also even provide us a way to do rolling updates and rollbacks. The important thing is, when you say I want replica 3, when you deploy it, it will attempt to make 3. And if it can't get 3, it'll keep trying until it does, or give you a whole lot of notifications that it's not quite able to do it. Then when you come to do an update, you change that deployment, or you change the pod definition in that deployment, it will now become a version 2. And what it will do is it'll bring in a new pod that is a version 2 and take out a version 1. This gives us a rolling update, so you can go bring one in a V2, roll out a V1, bring in another V2, roll out a V1. But you always have 3. It gives us a way to say, I always want to have 3 and still be able to migrate an application live from one version to another version without having downtime. So on to lab 3. We use the deployment.yaml that is found in lab 3. We're going to actually go ahead and create a deployment on the same pod that you just created in lab 2. So if you do kube control apply tac F on that deployment, you will see that there is now a deployment there that has a description. So we can do kube control get deploy. Then you'll be able to do kube control describe deploy. Now we're using deploy here versus deployment. We're just saving some characters. Kube control describe deploy lab 3. And this will give you a description of what's actually happening to that pod, what its states are, and what it's trying to do with pods. Then, here's the fun part. You can actually say kube control port forward deployment / lab 3, the same way we did to the pod name individually. Who's it the same pod? I see 2 now. Yep, you know what? I think we might have had a glitch there. So maybe we need to update that. So back where I was, you can then, the point is you can do that kube control at that point, and then you can get to any of the pods that happen to be behind that deployment. It will just pick one for you and get you connected. So let's go on to the next item. Now we're only going to touch on this one. We're not actually going to demo this one. Several stone pillars arose from a grassy knoll, and at the top of each sat a vulture. As Z and Fippy watched, one vulture spread its wings and flapped off into the distance. No sooner had one left than another took its place. Z asked, "What are they doing?" "Those are daemon sets," said Fippy. "They make sure to occupy every pillar, rain or shine, day or night." "I bet if we added a new pillar, a new bird would land on it faster than you could say cube cuddle," chuckled Fippy. And daemon sets are very much like deployments. The only difference is daemon sets do the job of making sure there's always one of these pods on every single node. This is really handy for configuring a piece of software, logging, or making sure that a piece of networking is active and functioning on every node to keep things happy and connected. So let's talk about service. And I apologize, the book doesn't have a page on this one. So Kubernetes has a concept of a service. It can be thought of as like a load balancer for pods. It's not a very smart load balancer, but that's okay. The important part is it knows which pods are alive, healthy, and ready to respond. So that when we try to access whatever pod we want to get to, instead of trying to connect to the deployment and getting the one we get, and then always asking that pod for work, instead, we can actually say, "I want to talk to this service," and the service will go, "You can respond, you can respond, you can respond," and just pass the work around up to all the available pods. So in lab 4, we'll use the service.yaml to create a service for all the pods that we just made. So we'll do the same kube control apply tacf service.yaml. Once you've done that, obviously check to make sure that it's actually working, because that helps, by doing kube control get service. You can also do a describe on that and to see more details. One of the things you'll see is a list of all the pods that are actually behind that service. When you have too many windows and you're trying to get things organized. There we are. Okay. So is everybody following along okay?
Oh, still pending. So those that are following along, I just was looking at the describe service, and one of the things I noticed is I don't have an endpoint, which is necessary for the service to work. Now, the reason I'm not getting an endpoint is my deployment is still pending. So I'll look at that while Jason continues. People can follow along and see what I'm doing to troubleshoot this a bit.
Yeah, I'm seeing that a few people are having that problem.
I wonder if it's just we're killing the API server. Although we shouldn't.
We may actually be. I'm watching that. Echo. Now this is the nature of going, let's stick 60 people on it at once.
Insufficient. Oh.
Oh wow, we may have actually exhausted the resources.
Uh-huh.
Oops.
It's only 150. Oh, It's 156 pods running. It's one instance.
Okay, tell you what, everybody, do kube control delete pod web service. So we're going to take out the pod we did in lab 2. The good news is everybody's web service seems to be up, but there's a bunch of lab 3s that are stuck. Sorry.
We're just hanging quiet because APIs are being hammered trying to kill everything. There we go.
Yeah, we're
Getting
going to
better.
start seeing a bunch rolling now. I'm seeing a bunch of them that are no longer failed to schedule are starting to come up as pending and starting container creating. So, all right. Thank you for calling that out so we can get that fixed. Note to self, fix lab 2 to point at the right thing, or not say in lab 3 that we're doing the pods from lab 2. Bingo, everybody's getting it working. Awesome. So next, now that we have that service, if you do a describe on the service, you'll get all the information about where your endpoints are actually at. See, endpoint line right there on Gerard's screen. So that's the address and the port of the pod on the inside of the cluster. So now we can get to that pod not by the pod itself or by the declared deployment, by actually going through the service by doing kube control port forward on service/lab4. Now, we'll come back to doing replicas and showing which one is which in a bit, if we have time. But now you're actually going through a networking service that's a virtual load balancer that's handing the work to the pod. So if you had 10 pods, you might get one request that goes to pod number 1, one that goes to 7, one that goes to 3, one that goes to 9. You get the idea. On to the next slide quickly. As they walked on, they saw an aquarium with an enormous reef, edge to edge. It appeared that the rock would keep anything from passing from one side to the other. Z watched as hundreds of tiny fish made a dash for the center of the face of the rock. At full speed, the fish swam into a hole bored into the rock face and momentarily vanished out of sight. Z let out a gasp. Multicolored flashes erupted from the opposite side of the coral, and instead of coming out of the single hole, the fish seemed to materialize from tiny fissures all over the far side of the rock. Ingresses are beautiful, said a dreamy-eyed Fippy. Enchanted, Z muttered, uh-huh. So an ingress is the last stage that we really want to point out today, since we're running close on time, but we have more steps later. An ingress is a way to actually route traffic around the services and pods within your cluster. They provide a single endpoint for multiple applications, whether it's HTTP or SSL or web traffic of various kinds. Many different implementations exist and allow you to customize for whichever platform that you're running on, whether it's GKE, AWS, K3 as we're doing right now, or Rancher or whoever's distribution or service that you're making use of. So we'll go right on to lab number 5, where once again, we'll build on what we've already got in place. Now, before you hit apply, I would like you to edit the ingress.yaml. And I want you to set the username to whatever your username is. That way, when we apply it, we'll all actually be able to reach it without stomping on each other's names. Also, bracket username isn't valid for a DNS address, so it won't know what to do.
Hence why you got the error I got. I totally forgot I had to edit, and I got the error.
DNS
like,
1123, the RFC says that's not allowed. Those characters are invalid, and we intentionally put the brackets in there to make it invalid to force you to edit the line. So replace that value, save the file, and then hit apply tacf ingress.yaml. Once you have done that, do a describe on the ingress whose name is lab 6. So kube control describe ingress lab 6. Oh, should it say lab 5? You're right. We have a text error. Thank you.
Yeah, sorry. Another little note too, if you're following Lab 4 specifically, try to hold off on doing the scaling up of that until after the presentation and we start clearing stuff out. Because I think in Lab 4 I have
Yeah, that'll
scale it to
explode.
4 pods. Yes, it
Yeah.
would.
It's great for example, Jamie.
But we'll leave the instance up for a while. Yeah, we'll leave the instance up for a while. So after the session, people can play a little bit and try to scale up and see things
So
happen.
once you've done a describe, what you'll actually see is it'll actually return the URL that you can use to access that. So you can copy that URL now, no port forwards involved, reach right out over the internet, hit the cluster, comes into the ingress goes, oh, that's bound for Gerard. That's over there in the ghickey namespace at the service. And then the service goes, oh, that goes to the pod over here. So we have your request in, hits the ingress goes, here's the name, which service does it go to? Over to the service goes, oh, I have traffic, I needed to answer. Who's up? Oh, over to the pod.
I'm gonna try this again. It sort of wigged out on me last time I tried to change screens here, but we'll try to change to the terminal or to the web browser so people can follow along a little bit. And see
Well,
the
I'm
same
seeing a
thing
bunch
I'm
of people
seeing.
post links in the chat, and they indeed work. So,
Yeah. Well, for those that aren't actually doing it, just following along on the video. There we
cool.
go.
Okay. So on to the next tidbit.
Right.
I know we're running close on time. If you feel that you need to go elsewhere, please feel free. I know we're running over. So the next thing, config maps. Config maps are Kubernetes' way of having a very simple key value pairs, and they're stored basically as objects, but they're in clear text. So they're very useful for doing things like pre-stashing environment variables or files that can actually be mounted directly into pods without actually having to have an actual file system somewhere. Now, you don't want to do things like stick application secrets in here. There's another object in Kubernetes called a secret. That's where those go. But we use them all over the GitLab Helm chart to configure all kinds of things like, what's my external URL? Where are my Redis servers? Do I have object storage turned on? How do I get to an SMTP server? Things that actually make GitLab function. We use this object, these config maps, to configure the GitLab.yml, equivalent to the Omnibus's GitLab.rb. But we put all the secret content into secrets because those are application secrets and they shouldn't be easy to read. Secrets. They're a base 64 encoded by default, but the data is automatically decoded when it's inserted into a pod. They can be attached as files and mounted like config maps or directly to the environment. And you can use add-on encryption providers like Vault or KMS. We're not going to cover those, but we wanted to touch them because you need to know the difference between a secure item and a clear text item. So in Lab 6, we're going to go ahead and create a config map. So if you want to go look in there, you can, but we're going to do kube control apply tacf config map.yaml. Now, the original deployment YAML needs to be updated in Kubernetes. This is why the name in the metadata key was not changed, nor were the labels for the identifying the pods that are associated with that deployment. Oops.
All right, I'm going to modify my
Okay.
deployment just a bit, add another replica, partly so people will see it transition from the single one I've got to two, and you'll actually see the existing pod that's running today terminate, a new one spin up, and then another one spin up off of that. So I've got K9S running there, so people will see that in pretty much real time. And let's go to 3. We should be able to get away with 3. So one's running, creating, and we should see one terminate here. Oh no, sorry, I said 3, not 2. So the first one sort of terminated fast enough that we didn't really see it. Reason I want to do that is because this lab, we've got the config map, which modifies our running configuration a bit and gives us a unique web page. We now have, let me switch over to the browser real quick. I think it's this one. If I reload the page now, we have a customized page, and you'll notice right down here in the corner, actually I'll make this a little small so it's a little bigger on everybody's screen. We have the pod that came from. And as we reload, that pod name will change to one of the
Right.
3 that's currently running.
So now,
Right?
So now, Gerard hit mute on my.
Sorry. So,
It's okay.
I'm sorry, I wasn't quite paused.
So now
thinking
you
something
can
else.
individually hit all the individual pods here. So here's the nifty thing. Remember when I said ingress accepts the traffic, looks up where the destination is, talks to the service, and then that service goes, I have pods that can answer this. How many do I have? Well, while you have one replica, it's always going to be the same one responding. But Gerard went ahead and made 3. So when he refreshes the page, he gets 1, and then he gets another one, and he gets another one, and it's picked at random. It's not quite round robin, but it's not quite favorites either. So the magic that we've tried to show you here, right? Because this is the end. The magic that we've tried to show you is this is what an actual container is, and this is a pod that runs a very simple container. Then we said this is deployment, and this is how a deployment manages pods. Paired to the deployment, we have a service. The service points at all the pods that match a label. We didn't cover labels, don't worry about that. You can look at it, and the lab exercises explain these in more detail. But the services point to the pods. The service acts as that kind of dumb round robin load balancer. And then the ingress provides a way to access that service from outside of the cluster. That's why we had to use port forward all the time until we actually had an ingress in place, because there was nothing that would let traffic into the cluster. So even if you tried to reach the external, nobody knew what to do with your traffic. So once we created the ingress, we gave it an external host name and said anything under / goes to these services. When it reaches the service goes, I have a request. Who's alive? You get to answer. You get to answer. Everybody gets to answer. And if Gerard were to still have 3 and just delete a pod, the service wouldn't route any traffic to that pod because it's not there and or it's not healthy anymore. So that's where you get that load balancing. You get the resilience because if a pod goes away, there's still 2, but the deployment is going to make sure there's another one that comes back. Then you get some of the magic of how do you actually scale. The answer is if we had the headroom to tell everybody to actually create 5 pods, you could see what happens when you have 5 pods, and we could point, Apache test bench at it and watch this poor CPU just kind of die.
Yeah. So two minor things. One, I just scaled up the 3 again. If I kill a pod, we get one that gets created and resumes. So we get that. The other thing I want to add, if you are done for the day and not going to play it around anymore, I'd ask that you delete your namespace, give us capacity. So if anybody else wants to play with scaling, they can. And the way to do that is kubectl, delete ns, and then your username. And that will get rid of everything there, all your pods and everything else. And I think we're pretty much
So yes,
at a wrap.
thank you to everyone who came out. We really appreciate you taking the time to come and learn. We really hope that everyone now has a much better understanding of how the magic of Kubernetes actually works as everything comes together. Magic is only science you don't understand. So hopefully Kubernetes is now real and not just mysticism. And let me take this last moment and say, Megan, thank you for helping us out and being a moderator and calling out a couple of items. We much appreciate it. And don't forget about Robert. He was there in the background, and although he had technical issues, he was helping to answer questions, and he was helping to keep us on track. So thank you to Robert, even though you couldn't be on screen with us today.
And thank you all for attending and coming and learning about Kubernetes.